Hey there, everybody. Thanks for joining our webinar today titled Trimble Unity RM 5.7 Release Briefing. I am Nick Frank, a producer at Trimble. I'll be the moderator for today's webinar. Before I hand it off to Dave, do have just a couple housekeeping items to get to. Our webinar today should take about an hour. That will include the Q&A portion at the end. To make sure we keep the flow of the webinar going, all attendees will be on mute for the duration of the presentation, but that does not mean you can't engage. There is a Q&A panel that you can submit any questions during the presentation. Dave's going to get to as many of those as possible at the end, and then maybe here at the start, we'll get to a couple questions as well. This webinar is being recorded. The slides and the video will be sent out in the next 3 to 5 days automatically, so be on the lookout for that. And we do have one poll question to partake in. So, hey, participate in the poll question once we get to that. And without further ado, let's jump right into it. Dave, hand it off to you.
Thanks, Nick. I appreciate that. So today, as Nick said, this is our webinar on the Unity RM 5.7 release. That release went out on August 8th. So many of you will have already been using this for about 2 weeks. So hopefully some of this is familiar. My name is David Baginski. I'm the product manager for Trimble Unity Remote Monitoring and also Kellogg Enterprise. And first, I just want to thank everybody for joining today's webinar. I know that there was some issues with the original email that went out. So anybody that got caught up in that, I want to apologize and thank you for your persistence and joining us here today. So the agenda for today, I'm going to go through the release initiatives and benefits, really, what's new and why are we doing these things. The headline feature is calculated measurements. So we're going to spend a lot of time on that today. And first we'll talk about it, and then I'll go into a demo and take you through a number of different calculations. And then at the end, we will have time for questions and answers. So the 5.7 release, as I mentioned, calculated measurements really were the headline feature. Within the software, we created a formula editor with an advanced syntax validation built in. So using this editor, you're able to build these calculated measurements. Those measurements are based on your existing RTU or imported data, extending the value of the historical data that you've already collected. We're hoping that these tools not only provide more insight and value in your data, but also reduce your reliance on third-party tools such as spreadsheets, Excel, Google Sheets, and the like. And anything that you create in terms of a derived measurement, a calculated measurement, will also be available through the Historian API. So these measurements will act just like any of the data that you're collecting with your RTUs. In addition to the calculations, we introduced a table-only view. So in the screenshot to the right here, you'll see 3 buttons that are circled. The first one to the left is the chart view. The center one is the new table-only view. And then the one to the right is the mixed chart and table view. So this came from feedback from several customers looking for a way just to see the raw data values. And then we've also improved our navigation. So we're adopting more of a breadcrumb style navigation throughout the application. You've seen this already with our remote monitoring settings pages. We've now brought that into the navigation for reports, as well as the calculated measurement creation process. So you'll start to see this show up in other places as well. Eventually, the entire application will be consistent with this style of navigation. So let's look and talk a bit more about the calculated measurements. As I mentioned, there is a new formula editor. This editor has a lot of nice features that are built into it, making it easy to create these calculations. For example, you can drag and drop measurements from the measurement panel over into the formula editor. There's also an autocomplete feature. So as you type and enter characters, you'll see a list of matching names that you can then select from to help you complete that more quickly and accurately. As you enter formulas, you'll see syntax validation and a small red X appear if there's anything wrong with the current syntax. It's designed such that it doesn't impede you from continuing to edit the formula, but will alert you if there is something is wrong and it's been detected. There's a drop-down operators list. So it's highlighted here in the screenshot. When you hover over it or click on it, you'll see a list of all the different operators that we support. You can use this list then to click on one and insert that into your formula. It also serves just as a handy reference guide when you're trying to remember how or what operators are available to you. Not mentioned in the list here, but highlighted in my screenshot. You can also click on the 4 arrows to produce a enlarged dialog for editing the formula. So if you're working on a smaller laptop type screen, you can use this to give you maximum space for editing these formulas. And then the last thing about the formulas is each formula that you enter has a start time, and that start time will dictate when that calculation begins, and that will continue until the next formula is encountered. So you can actually have multiple formulas defining one measurement, and they would change over time depending on the start date that you enter for each of them. The supported operators, so we have the basic math operators that you would expect. There's also trig functions. There's Boolean operators and logical operators. So if you were to use our built-in if then else statement, you can create complex tests that would then test if one or more conditions is true, and then decide what operation you want to perform. And this will be more clear as I go through the demo and the examples after. I'll show how this works. So what do we use the calculations for? What are some examples of calculations that we support? One would be if you're working with pressure data and you want to take that PSI pressure data and normalize it to feet. So sometimes referred to as water column. You can do the math and convert PSI to feet, and then compare your different metering locations normalized to the same height. I'll show an example of how to do that. Net flows. So if you want to take multiple flows that you are monitoring and combine them in some way, add them together, for example, to get a total flow, you can do that, and that's another example that we'll run through. In a similar fashion, if you're working with water distribution networks and you want to do some water balance where you're adding in your inflows and subtracting out your outflows and determining your water loss or non-revenue water, that's also a possibility. Surcharge level monitoring is a key one where you would want to utilize an if-then structure. For example, if you have two sensors measuring level, you might have an ultrasonic that is your normal level monitoring sensor, and a pressure sensor, which would be used primarily during surcharge conditions. So what you can do then is set up a measurement that would give you your combined level, where it would select the ultrasonic sensor if you're below a certain threshold, and then switch over to your pressure sensor when you exceed that threshold. Just a few more examples. Being able to calculate your flow rate from a weir or a flume. So for those of you that may not be familiar, take a look at the picture of the weir that we have here. It's basically a structure that's built with very exact specifications. And by measuring just a level measurement up by where you see the bridge here, you're able to perform a calculation that will give you the flow rate through this device. So very, very nice way of computing flow with just a single level measurement. And using calculated measurements, we can now capture that equation and do that conversion or do that calculation in the software. Other uses, unit conversions, switching between inches and feet, for example, or perhaps in a more complex way, switching from a flow rate to a flow volume. We can do data adjustments. So if you have data where you know that there's a problem with the data that you've collected in the field, either there's an offset or there's some scaling issue with the data, you can provide calculations to perform the correction on the original raw data that you collected, producing a clean measurement then as a calculated measurement. Aggregation's another option. If you want to take interval data, 5-minute or 15-minute interval data, and report on it as hourly or daily values, you can do that. Now, that sort of capability, some of these are the other ones as well, that is available in our reporting tools. But if you wanted to make this data available, easily accessible or available through the API, having these measurements set up would certainly make that faster and easier. And then the last one I want to mention are baseline indicators. So in many cases, you may just want that constant value. That value might indicate a pipe diameter or a manhole depth, or perhaps an alarm threshold. And you want to be able to show that on your chart with respect to your data, giving you a sense for how close you are to that key level. You can create those baseline indicators as well. So that was quite a bit of information on calculated measurements, and I want to spend some time going through a demo, and we're going to go through about 5 different examples of calculations to see how you would use the new tools, and hopefully this will spark your interest, and you'll want to go afterwards and try this out yourself. I'll pause there for a second, Nick, just to make sure that there's no questions yet.
Not at this point. Nothing coming in yet. So just keep rolling, Dave.
Perfect. Thank you. Okay, so I'm going to switch over here to Trimble Unity Remote Monitoring, where we have our demo data set. And let's start off. The first thing I want to do is a straightforward calculation where I'm going to take one of my rain sites. We'll search for it. And I'm going to produce a measurement that will be the daily total rainfall. So let's go to my measurements here and find my rain measurement. And bring this up. You'll see the rain data plotted on our default Y5 axis. Let's look at a bit more data to get a better view of what's going on. And this data is being collected as 5-minute interval data. So I'm going to click over here where we see this new button. This is the Create Calculated Measurement button. It's part of our telemetry report measurements panel. When we do that, you have now the options. We can enter a name. Daily rain is what I'm going to call my first measurement. A optional description. I suggest filling this in because you'll be able to see this description when you're looking at your measurements. A type, we're going to select rainfall daily. The inches and compression units will default, and we'll keep those. And then finally, we create the calculation itself. So we have our dialog here that comes up. The first thing you need to enter is a start date for your calculation. We'll start June 1st, and an interval length for it. Since this is daily, I'm going to enter 24 hours as my interval to give us that daily total for the rainfall. We'll drag the rain measurement over here into our formula, drop it, and it automatically places it into the editor. Now, that's it. That's all we need to do. We're going to take the rain measurement and we're going to aggregate it over a 24-hour period. Because rain is set up to sum by default, when we do this aggregation, it's going to sum the measurement. And that's part of the measurement configuration. So we'll save this. And that saves our formula. And now we'll save the measurement. And you'll see it show up here in our panel. Hovering over the measurement shows you your tooltip, as your description as a tooltip. And then here we have a little indicator telling you it's being calculated. That indicator goes away when it's completed, and we can add it to our report. Now it's a little tough. We have both rains on, so I'm going to turn off the original. And let's look at the new table view. And here we have our daily values showing you the rainfall for each day. If we turn on the original 5-minute interval rain data, you'll see that on the right here, and our daily values, which of course are much sparser on the left. So let's go in and go to our settings and change the compression of this report from default to daily. This is going to allow us to quickly compare our calculated measurement to our reported values here. And you can see, as expected, we have a perfect match between these measurements. So yes, there's two ways to arrive at the same result. One, using a report and applying compression at the report level, or two, using the new calculated measurement to do the compression. Having that measurement available to you makes it much easier to use that in combination with other measurements so that you don't have to do that compression at the report level. Yeah. Bear with me for a second. We'll glitch here with the screen freezing up. Well, I apologize for the issue here with the demo, but give me a minute and we'll get this going again. Okay. Okay, sorry about that. Now we're going to resume here with the second calculation I want to present, and that is a net flow style calculation. So we're going to use our flow sites. And I'm going to start with this first one, Northwest 1. And similar to the other calculation, we're going to go in here and look for our flow measurement. This search is new as well in this release. So once I have my flow measurement and bring that into the chart, let's back up so we see a full 7 days of data here. Now, I can also see all the other measurements for this site, but I'm only interested in the flow measurement. So I'm going to filter by flow. And then what I want to do here is add some additional sites to this report. It'll make it easier for me to then work with these in the formula editor. So I have other flow sites in the Northwest region, 4 and 5. I'll select 2 more. You'll see them in my list. When I add them, their flow measurements will show up here as well. Keep in mind, if I wasn't filtering by flow, I would see all of the measurements for these sites in this list. So at this point, I can turn on the flow measurement for sites 4 and 5. And now I'll have 3 flow measurements here in my report. At this time, I want to combine those 3. I'm just going to check out the interval length. The interval length is 5 minutes for this data. I need to know the interval length when I get into the formula editor to make sure I enter a formula interval that's compatible with the data I'm working with. So I'm going to create a measurement called total flow, and I'll give it a description. And that'll be the Northwest flow, and then we'll select the net flow type, which is a common type used for combining flow measurements. We'll go into our editor, and again, we'll select the start date back in July this time. Our 5-minute interval that we looked up, we'll enter that here. And now we'll filter this as well by flow. And now let's bring our flow measurements in. So first we have the N1 flow, and then we're going to add to that the NW4 flow, and then add the final one for the NW5 site. So we have all 3 flows summed together in our editor. We'll save that formula, and then we'll save the new measurement that will show up here in our list. It's still calculating, so we're just waiting for that calculation to finish. Once it does, we'll get a prompt to refresh our data. And we should see that new measurement show up at the top. Since it's the sum of the other 3, it's going to have the greatest magnitude and show up here at the top of our list of our chart. We can switch to our table view and see the 4 measurements now, where the sum of the first 3 equal the last one here, the total flow. We can also go to our summary panel and just confirm that the sum of the first 3 flows equals the total flow as well, which it does. And then the same as you can create measurements, you can also delete them when you no longer need them. So in this case, I'll just demonstrate how you delete one. And once it's been deleted, it's removed from the report automatically. So that's an example of how to create a net flow. Water balance would be basically the same process. So next, what I want to do is demonstrate how we do a conversion. Again, we're going to stick with flow for this, and we're going to do a conversion between flow rate and flow volume. So this will be converting millions of gallons per day to gallons. So I'm going to go and find for my NW13 site its flow measurement. Let's look at a bit more data. Okay. Again, checking the interval length here. This data is also 5-minute interval data. And so let's go ahead now and create our calculation. And I seem to be having the same issue as before. Let's give this a second. Never fails. Okay, so we missed a bit there. So the demo is done through a recording, and unfortunately, the recording playback is having trouble. So I'm going to back up just a bit here. Bear with me. I want to pick up from right here. So this is where we should have been. So here we're going to create the flow volume measurement. So this is a flow rate converted to a volume, and we have a flow volume measurement type. So we'll select that, which sets my units to gallons and my compression to sum, which are what I want. And then we'll set up the calculation to do the rate to volume conversion. So just like before, we'll set a start time. Go back to June 1st, and we'll set an interval length. Again, matching the raw data that we're using. We'll type this time. So you can either type the measurement name directly, or we'll type the site name or select it from the list, just to show you how a bit more how this editor works. If you're typing, when I type a period, it shows me all of the values that I can select from. So I want the flow measurement, and then the closing brace bracket encapsulates the measurement name, the full measurement name in this case. So let me show you the operators now that we have available to us. We have all the standard math operators, trig operators, some Boolean and logical operators, and then there's a few constants that have been defined to help ease the input of those values. I'm going to choose multiplication, which basically just puts the star into the formula, the multiplication symbol. Now we see that there's an error because I haven't defined what's on the right-hand side of this multiplication yet. So I need to enter something here. And since I want to work in gallons, what I'm going to do is multiply it by 1,000,000, because we have our native raw data is in millions of gallons per day. So by multiplying by 1,000,000, I'm going to produce gallons per day from that RTU measurement. Next, I'm going to divide by 86,400, which is the number of seconds in one day. So now I will have gallons per second in terms of the value that I'm calculating. Last, I have to multiply it by the interval length. My interval length is 500 or 5 minutes. And when you convert 5 minutes to seconds, you end up with 300. Now, I can combine all these constants into one value and do it that way. But sometimes spelling out the whole calculation like this helps you when you come back and look at it to figure out what you're doing, you know, why you entered the value that you entered. So this will give me the data expressed in gallons for a 5-minute interval, taking that rate and converting it. So here's my flow volume measurement. I can turn that on and we'll see it on the chart. Now it's already finished, so I don't need to refresh the data when it comes up with the prompt. The blue lines are new calculated measurement. It's in gallons. The legend is on the right-hand side here, and the original flow measurement is still on the chart as well. And then unfortunately, we're continuing to have problems. So, okay, so we'll switch to the table view. And the table view is going to show us both the flow rate on the left and the flow volume then on the right, which is our new calculated measurement. Well, thank you for bearing with me on this. So what I did here is I went back and turned on the summary information, because what I wanted to show is that the sum will agree between the flow rate, which converts it to millions of gallons, and the new flow volume, which is in gallons. So that M on the end indicates millions. So we're seeing 230.4 million gallons, whether we're looking at the calculated flow volume or the original flow rate that we recorded. So just confirmation that what we did with our calculation and the math we applied makes sense. All right, so switching up to a different type of example here, one that doesn't work on wastewater flow, but instead we'll look at a pressure site. So I'm going to go to my Aurora HPR site, where we have, this is a hydrant pressure recorder, where we're recording pressure as PSI. And here I want to create an elevation. We can do that without going to our chart first. We have the button as well here. And the process is exactly the same, where you enter in the name, a description, the type information, elevation in this case, verify the units and compression are correct. And then we'll enter our formula. The process here is still the same. Just expanding over here to point out that there is help right in the formula dialog to give you some examples, but there's also far more extensive help in our online user's manual. Just search for calculated measurements to find it. So we'll back up again and start this on July 1st, which will be sufficient for us today. And this is 1 minute interval data. I had checked this previously. So we'll bring our pressure over. And what we need to know is the constant, which is 2.31, which converts PSI to feet of water column. And that's just something that you can look up online to find that constant. And then what I'm going to do is add in an offset. So we're looking at feet. In this site, if I had some survey information, and I don't, I'm just going to make this up. I'm going to say that this site is 160 feet above sea level, plus whatever the pressure is at the hydrant gives us our total elevation based on the pressure. So I just add in the offset that way. But once I save this and save the elevation measurement, I'll see it show up in this list the same way it would in the telemetry report. So it's still being calculated. I don't have to wait for it, but it's done now. So let's go in and look at the pressure. Our elevation also shows up here. So we can see the pressure, and then we can turn on the elevation, which of course is going to look very much like the pressure, but it's going to be converted into feet. And you can see it in another view, in the table view, again, PSI and feet. This data can be exported from here as well. And then lastly, we also have the split view. So this view was in the previous releases of remote monitoring. Now you have 3 choices instead of just the toggle for 2 choices. Well, we have one more example to get through, so hopefully my computer will cooperate long enough to get us there. In this example, what I want to do is use a level site instead of a pressure site. So we have something called the Crest Creek level site here. And this is the site where our weir is installed at. So remember that picture that we saw in the slides before we started the demo. So from here, what I want to do is find my level measurement. And then here it is. We'll click on that to create the chart. And we'll include some additional data here. We'll just look at 2 months, June and July, for this measurement. And here we have our level data. This is also 5-minute interval data. So once I know that, I can go in and create my first calculated measurement, which what I want to do is take this data and just convert it to feet. It'll make what I want to do subsequently easier by having a converted measurement already converted into feet. So this is pretty straightforward. It's just going to be level in feet. We'll give it a brief description. I've created a measurement type already. So I have something called level in feet, which has default units of feet. And then the calculation by this point should be pretty straightforward to come up with. We're just going to enter a start time, our 5-minute interval. We're going to use the level data and level. And then to convert inches to feet, all we need to do is divide by 12. Exactly. So that's all there is to it. We'll save this. And I can plot this on our report. And there it is. It's going to prompt me here to refresh the data once it thinks it's completed. I can choose to do that, or I could have not done it as well. So that's our first calculation. There's a number that we're going to build up here. Our next calculation is a little bit different. It's going to be our max level. This weir installation can only read and work up to 4 feet of depth. So my max level is going to give me a visual indicator as to where 4 feet is on the chart, but we're also going to use it for something else in the calculation of the flow. So I'm just going to create this measurement. I created max level already as a measurement type. Same drill. We have to go in and set a start time and an interval length. We'll use the same interval length. And now our formula is just 4 feet in this case. But we need to do something a little bit extra, because if we just enter 4, we won't automatically update this measurement as new data comes in the future. So we need to reference another measurement that will have new data coming in. So that's our level data in this case. We could use any of them, but I'll stick with level. We're going to multiply that by 0, which of course will be 0, and add 0 to 4, which of course will always be 4. So this is kind of a trick to learn to create these type of indicator measurements. So once we've done that, it will calculate this one as well. Adding it to our report, you'll see a line right at 4 feet. And this comes up because it just finished the rest of the calculation. So there we have it. Now we have our level in feet. We have our max level, which is our 4-foot indicator. Now this could be anything we want it to be. It could be an alarm indicator. It could be a maximum pipe size. In this case, we're using it as a maximum level measurement. So now the next measurement that we need to compute is actually our flow rate through the flume. And this is going to rely on an equation that the manufacturer or engineering firm that builds the flume must provide in order to calculate the flow rate through that device. So here we're going to have flow as gallons per minute. That's my desired output here, is the gallons per minute. I could create any unit I wanted to. So, but we'll stick with that. Gallons per minute. And then we'll come into our formula editor, and I apologize for jumping ahead here. More of the same issue. Do appreciate your patience with the screen performance here. Come on. All right, I have to back this up or we're going to get lost. So bear with me for one more second. Okay, so now we're in the formula editor, and this is going to be a little bit different. We're going to use an if then else construct. So to start it, I have to enter if in an open parentheses, and then the measurement I'm referencing is level in feet, and the comparison I'm doing is against max level. What I want to know is if level in feet is greater than max level, we know that we can't compute an accurate flow for that condition. So we're going to cap it at max level. And this formula that I'm entering now is the flume formula for a 5 foot wide flume. So that 5 is indicating 5 feet wide. And I'm going to use the max level because I know anything greater than max level won't work. And then the last thing I'm going to add here is 448.83. This is a constant. This constant will convert from cubic feet per second to gallons per minute. And it's something that you can easily look up online if you need it, because the output of the flume or the weir calculation is in cubic feet per second. So if you just say convert cubic feet per second to gallons per minute, this constant will pop up. And then the other half of the if then else is the else. And in this case, I'm going to use the level in feet because we're less than the max level. Same formula otherwise. So really the only difference between these two conditions is which level measurement I reference, either the max level or the level in feet. So just read through this one time. If the level in feet is greater than max level, calculate the flow using max level, a constant. If the flow level in feet is less than max level, then use level in feet and do the same calculation. So that's the way you would read this. Now, the fact that I put returns in, that formatting is just to make it easier for me to read. You don't have to format it that way. So we'll save this and we'll have our new flow rate calculation measurement show up. We can add this to our report. I'm waiting until it's done calculating. We'll see our tooltip come up here in a second. Okay. There it is. It's done calculating, so we should be able to add this to our report. And this yellow gold measurement now is our calculated flow rate in gallons per minute. You see that on the axis at the far right. I'm going to turn off level. It's not needed for our comparison here. And then, so now we have just the level in feet, the max level, and then we have our flow rate. Let's zoom in on this region here at the very beginning. where we can see our level in feet has exceeded the 4. And as a result, the calculated flow rate is clipped at a constant value. That constant value is based on the max level of 4. And then once our level drops below 4, drops below the green line, you'll see our flow rate then trickle down and track again. So that's showing that our if then else calculation is working as we expected. But the other thing that I want to show, and this will be the last calculated measurement that we create, is that there's often more than one way to do the same sort of calculation. So I used an if statement in my last one. We can avoid using the if statement and kind of streamline and simplify the math for our flow rate. We can get through one more, hopefully, here. And okay, sorry, we jumped ahead too far, so I need to back up again. Since there's only one more, we'll work through it and grin and bear this last one, hopefully, and be able to complete the demo. I'm certainly sorry for the technical difficulties. Okay, I backed up enough. So we're creating flow rate 2. Everything's going to be the same except for the name and the calculation that we perform. So let me just select the start date and the interval length. And we're going to enter the same WEIR formula that we did for the other one. The difference is right here. We're going to use the min function and select the minimum value of either level in feet or max level. So whichever one is smaller is what the min function will return, and then we'll just finish the rest of the formula. The end result is the logic is exactly the same as using the if then else. It's just a more compact way of writing the same thing. So we can save this and calculate this. And the last thing I want to do is just prove that my assumption is correct here, and that we'll get the same results for both calculation. And you can see it visibly on the chart, and we can also see it and confirm it in the table here. So there is more than one way to write the same calculation many times, and it just comes down to a matter of preference. So with all the difficulties with the screen lag there, we did make it through the demo. I appreciate everybody sticking with us here, and I'm going to take an opportunity, one, to see if there's questions, and two, Nick, did you want to do that poll real quick right now?
Yeah. We'll launch a poll here based on the demo, just a little bit of information. Are you likely to use calculated measurements in your data analysis? Are you very likely, maybe, or unlikely? And while we do that, we'll also, again, open it up to questions. We got 5-10 minutes here, so feel free to throw anything in the Q&A panel, and Dave will get to as many as he can here.
Well, while we have the poll up too, I'm just going to point out one thing in the software. If you're familiar with how to navigate to the online help within remote monitoring, you may have seen it or you may have missed it. there's a separate tab right next to the default tab, and I have it circled here with the square red rectangle. If you click on that tab, you're given an opportunity to write in either a product enhancement request, or general feedback. And that information goes right to our product team. Our product team will review every request that comes through. And I would encourage you to take advantage of this and provide feedback to the team and request features that you'd like to see in the software that you think are missing. And since it's right here, conveniently located, you can do that pretty quickly without interrupting your workflow. So I'd encourage everybody to consider giving us some feedback on the product or requesting something that you think is important and needs to be in the product.
So Dave, I put up the results of the poll here. About 56% saying maybe, 38% very likely, and 6% saying unlikely to use calculated measurements.
Well, that's good, because I think that the maybes will become very likely once they start seeing the different applications for it. So thank you all for participating.
Yeah.
So that brings us to the end of the formal presentation. Still have a chance if there's some questions that have come in. I'd be happy to answer those.
Yeah, we got a few coming through. I think this one kind of was answered asked pretty early in the presentation, kind of right before the demo. Does the calculated measurements feature allow for converting fire hydrant pressure to flow rate using a diffuser?
Okay, yeah, so fire flow, that is an application that we are looking at supporting. I will have to do some investigation to figure out what, if anything, is missing to do that. I know that we do that through a differential pressure measurement that we've done through our other software platforms. But great question. I'll look into that and get you a more definitive answer on it.
Awesome. So kind of I think, is there going to be a step-by-step instructional manual? Is that going to be available for some common calculations, maybe some written documentation?
Yeah, so that's a question that has come up by another user as well. And within our current documentation, we do have pretty good descriptions of what the fields are and how to use them, but it's lacking examples. I think that this presentation and the subsequent recording will help fill some of those examples, some of the gaps there, until we can actually write that out in a manual format. I think including some examples right in our documentation would be very useful. So that's been noted, and certainly something that we'll look at doing. Now, by the same token, if you're attempting a calculation and you're not quite sure how to do it, bring up that feedback dialogue and tell us what it is that you're trying to do. And we'll probably be able to give you some quick help on first, whether or not it's possible, and then second, how to do it. So I encourage you to do that while you're thinking about it.
As a user, is there anything I have to do on the units to update them?
To update them, so I'm not quite sure if the update them is referring to using calculations or if it is referring to something different. I'll address the calculation question first. The calculation question, no, this is a feature that's turned on for all of our users of remote monitoring. For a unit, there's a couple of different types of updates in the RTU. One is a programming update if you want to change a configuration setting. And if you haven't done that before, you basically go into the settings dialog, make your changes. It becomes a pending configuration, and that's applied the next time that we communicate with that unit, and you'll see the pending flag go away. The other option that you could possibly be talking about is a firmware update. If you need the firmware updated on a unit for any reason, reach out to support, let us know, and we can enable that on the back end to make that happen. That happens over the air. It's not a feature that you can turn on yourself at this point using just the software and remote monitoring. So I hope I answered the question. It was one of those. If not, just reach out to us and let us know what the question was actually.
Okay, I think that did answer the question.
Great.
So I think we'll get to just one more and then we'll have to wrap up here. Can you provide the calculation for elevation conversion? Is that in the system as well?
Yeah, so I demonstrated that, assuming that you want the elevation expressed in feet. And so if there is something that's still missing on that, then let us know, because we can write up a quick note and pass that along. And I will see that we get some more examples in the documentation. But in the meantime, when you need something like that, let us know. I'm happy to help myself, or one of our support engineers can also help with many of these questions. So yeah, feel free to reach out anytime. We're happy to do that. Happy to hear from you.
Awesome, Dave. Well, I think that's all the questions we have. Do you have anything else that you want to close with before we wrap up?
Just simply thank you so much for joining us. Thank you for your patience during the technical issues. Sorry about that. And I really look forward to any and all feedback on these new features. So, please talk to us. Happy to help out any way we can. So thank you all.
Yeah, that's all the time we have for today. Great job, Dave, with the presentation. Once again, the video and the slides will be sent out to you in the next handful of days. So if you want to send it to a colleague or something like that, that will be sent out in the next few days. If you have any additional questions, don't hesitate to reach out. And thanks again for joining, and we'll see you on our next big webinar here at Trimble.